should be live now. All right, so this month we're going to be talking about Cloud Code 3.0 and its new experimental features. This was released about a month or so ago as an experimental branch of Unity Cloud Code. And this gives us some very useful features for multiplayer and using it with Cloud Code. We did a little talk on this last year, I believe, about going serverless with serverless architecture without needing to spin up dedicated servers or even relays between different players. So Cloud Code is really good for something like a turn-based game, like a card game that we're going to talk about here, and also for some, you call it asynchronous multiplayer. Mobile games use these a lot, where you take a turn and it can be, hours or days before the next person takes their turn. So we'll look at how Cloud Code can now keep track of game states over longer periods of time. All right, and if you guys have any questions, feel free to drop them in the chat or in the comments of the YouTube video if this goes up later. And yeah, we'll address it as they come on. All right, so first thing I want to talk about is actually getting the new features installed here. And by default, the Cloud Code, I think, is still at 2.0 here. When we open it up, if you install this Cloud Code regularly, you might end up with a 2.10 version, but we are currently on 3.0-exp.9, and you can install that from the package manager if you just install com.unity.services-cloudcode, and you can specify the version number here. You click on the plus, go by technical name, the package, and then the version number, which would be the 3.0.0-exp.9. Okay, and what this will actually get us, go back to the docs here, is a couple of new features. One is the stateful Cloud Code, which will have various scopes that the Cloud Code will keep track of over extended periods of time. Before, we would have used Cloud Save to save these variables and game state for other players to actually look up. But now this is all done within Cloud Code now. There is a local Cloud Code server as well now, so you can do your testing without having to upload your modules up to the cloud and run everything there. That will save you some time and, more importantly, money, because Cloud Code it's got a free tier, but you could potentially go beyond that free tier if you're doing a lot of testing. So the cloud code, local cloud code server is really helpful for that. There's a new way of actually creating your cloud code modules now. Before you had to create a whole separate solution within your project. Now the deployment will handle all of that for you. So you just create it directly in the editor and your files will live in the same project as everything else. State serialization in the cloud. Yep, we will cover that. And we also have timers now. So Cloud Code can keep track of timers up to 24-hour timer, I believe it is. We'll look at that in a second. So things like turn timers, if you wanted a 30-second turn timer for a card game, which we'll look at, you can do so. I've got a 90-second timer set up right now, so it will automatically end the turn if you haven't completed your turn by the 90 seconds is up. Okay, so let's look at some of the rest of these docs here. So also, you will need to be on Unity 6.3 or later in order for this to work. So that's something to keep in mind. All right, so for state persistence, there are two new state scopes that you can create your modules under. And also, I don't know if you can actually mix these or not, but there is a scope for the player, which are only accessible to that specific player. So if you have something kind of local-ish that you want only that player to have access to, you can do it that way. This would be things that would persist for the lifetime of this player, which I think the default is 2 years. So this would be like long-term things. So character, player levels, inventory, things like that. You can save things to this scope. I would probably still use Cloud Save for something like this, but it's no longer necessary to do it that way now. There is also the multiplayer session. So this will be what we are going to be using with the card game. So this will be data that is scoped to the multiplayer session. So what you could do is you would create a lobby, and everybody who joins that lobby will have access to that lobby session ID. When we initialize our cloud code, we will initialize it with that same session ID, and then everybody gets access to that game state. So we'll be using this for our card game state. So whenever someone plays a card, attacks a monster, whatever, that will update the game state. It will be saved to this session scope, and then anybody who logs in with that session can see any of that data that is updated. And we'll show how we can monitor that and send messages back and forth without having a real-time connection. So in order to do this, you have an attribute for your class, your module class, and you give it the scope, state scope, scope.player, or scope.session, multiplayer session. I think it's scope.session. We'll look at our code here in a second. By default, any public variables will be automatically persisted. If you have private variables here, you'll need to use this cloud code serialized property attribute on it. So yeah, and also if you want something to be ignored by the serialization, you can use the cloud code ignore property here. This part here is just showing how you would end up getting the player ID to scope your player scoped modules if you wanted to. So this is the same player ID that you get from the authentication service here. So when they log in, either anonymously or through the Unity player account system or wherever, you can log in with Google or Facebook or GitHub. There's a number of different authentication services you have access to through Unity authentication services. And once you get a player ID, then you can go in and here, it actually doesn't show how to actually, we'll go over that in a second. And also for the session ID, this is using Unity sessions. So this is not quite like using the relay and lobby system separately that you could do before. This is using the sessions API. So this is using the multiplayer service.instance.create session. There's also quick join, create and join, matchmaking as well. You can do all of that through the sessions API. And then once you have your session ID, you can save that off. And then at that point, that's where you can initialize your cloud code module using it, and then grab any of your existing state here. So this session does not have to create a network. So you can see this is just creating sessions with no network here. So this is just a session with max players of 2. And that's it. So there is no network being created with this session. So it's technically would just be a lobby. But after this has been created, you don't have to create it again. You can save this in player prefs if you want, or save it to cloud save. If you want to have it between devices, you can do that as well. And then once you reinitialize with the session ID, then you can come back to this game at any time. Well, I guess within the 7 days, I think it said it was. Yeah, player state is 2 years. Multiplayer session state is 7 days. That's by default. I don't know we have a way of changing this default just yet. And that might just be, I don't know if that's 7 days from the last update or if it's 7 days from creation. I would have to actually test that. Okay. And then when you are actually creating your module, this is with the automated bindings that it will create for you once you create your module. And you just create a new, whatever you called your module. And then for this one, it's player scoped. So you give it your player ID. and a instance of your cloud code service instance, and then this will sync up with that player ID. If you don't use the automated generated bindings, you can just call it from the cloud service instance itself. And this is just using the call module endpoint nsync that is used normally for cloud code modules. And then you just give it your the name of the module, the name of the function that you're calling, and then you can give it the scope for that module. They can't be mismatched. So if you call a player scoped module with the session scope or vice versa, you'll end up getting a error message. So that's something to keep in mind. Okay, the local cloud code server, we will show that here in just a second here. And developing the modules, yeah, we'll look at that. State serialization, yeah, we don't have anything to actually add to that. And the timers we will look at in a bit more detail in just a second. Okay, yeah, and I implemented a turn-based timer. I forget which one of these I actually ended up using. I think it was this one here, this cancel a timer. So if someone actually makes a move before the timer runs out, it'll cancel the timer and then restart it. But let's go ahead and look at Unity here. Okay. So after you have it installed, you'll want to go into your menu. This is to start up the local cloud code server. And you'll want to go down into services, and you need to check cloud code here. With that checked, you'll have a new icon here, new cloud icon, which is real close to the actual services, but right now it's a new one. So when you click the drop-down menu, you can actually clear your local server state if you want to, or you can start the local server. You'll need to start the server first before you start your game. Oh crap, I don't have .NET Core on my, oh my god. Okay. Well, might not. Yeah, I'll try this real quick. I forgot this is a new laptop and I need to install .NET on here. We will try this. Hopefully this won't take too long. well, that's coming back up. We'll talk about the timers here. So the timer has a new timer service that you can grab from. It'll be automatically injected when you create the module through a dependency injection here. And when you create your timer, you will register a timer, and then you give it a time span and also a callback. So this will happen after the timer runs out. And then to cancel the timer, you would need to get the timer first, and you have it from the timer ID that we saved here. This is saved as a serialized property here, so anybody who initializes this timer with this session ID will grab the same timer, so they will have it'll be synchronized to everybody here. This one is a 30-second timer. And to cancel the timer, when the user actually completes anything, you will just call the timer.cancel. And then don't forget to set the active timer to null since it's no longer active. And keep in mind that the module can only have 10 active timers at a time, so you can't get too crazy with all of your timers. Is Unity opening? Okay. We are back. And let's try this again. Oh, God. Okay. All right. Well, I'm not going to be able to test the local server, but you really don't see any difference here. So what we'll do here, we're just going to deploy it to the actual cloud. And there we go. We're all up to date. Okay. If you do make any changes to your Cloud Code module, these will no longer be up to date, and you just need to make sure that you redeploy. So actually making the new module, what you'll want to do is right-click somewhere in your project here, which we can let's make folder, and we can call this we're not actually do a full project here, but we'll just call this Uno Cloud Code. So here, you'll want to do it in an empty folder because this will create a couple of different folders, and there's some other code generation that will happen here that you don't want to get mixed up if you're doing multiple modules here. So you want to go down to services, and you'll want to do a cloud code module script, not the cloud code module reference. This is the old way of doing it. There's also a cloud code JavaScript script. You don't want to use that either. We'll just be using cloud code module here, so we can do it in C#. We'll want to name this as Uno Cloud Code. There. Here we have a module creator here. And you'll just want to call it something here. Well, we just named it the Uno Cloud Code Module. Here, our script is just going to be cloud code. That's fine. The client is going to be automatically created. The client will be how you actually call it from your actual game code. And both sides will create assembly definitions for you. Okay. So now you see here in our deployment window that the new cloud code module automatically shows up here. We also have a module here, and we can just show that down here. And then we have our actual code. Okay. So yeah, here is just the default sample template that they give you here, and it's automatically scoped to the player. We have a cloud code function. There we go. If you wanted to scope it to multiplayer session, you could do that as well. And also, the really good thing about the local cloud code server is that you can run debugging on your modules before when it's out on the cloud. It's actually extremely hard to get decent logs out of your modules, and when something breaks, it's hard to tell and track down what exactly is happening without a bunch of debug log statements. So yeah, now we can deploy everything if we so want, and our Uno cloud code is now deployed. The client here is actually empty because this will get generated at runtime. So once you actually create a new Cloud Code client, then you'll be able to call whatever that hello world player function was. So this code here, you don't want to actually mess with any of that. Okay. So let's look at a module I already have created here. All right. We'll go over the cloud code bits first here, and then we'll take a look at the card game battle framework that I found here recently. And then we'll dig into the actual card game mechanics and how that all will come together once we get everything set up and running here. Okay, so first thing we're doing here is we are saving off some of our services and APIs that we'll be using within the actual module here. These are going to be private, so these aren't going to be serialized, which is fine because these will get recreated whenever you actually start running the cloud code stuff here. Here in our module constructor, we are grabbing the push client, which is how you will actually send messages to other players, even though there is no real-time connection to them. If they're online in the game, they will get a message pop up. And they also have to be subscribed to receive cloud code messages. It's different from push notifications on mobile. Those you will actually get regardless of whether your app is open on the phone. It'll be pushed out as a phone notification. We also have a logger. This will help for troubleshooting again. The timer service for our turn timer, and also the game API client, which I think I'm using for cloud save. I don't remember now. So our public states, these are going to be persisted here. We've got a string game state. This will be a JSON string, I believe. Our active turn timer and the turn time limit. I guess we can actually, because this is getting into the actual card game stuff here. But I did want to here we are starting our turn timer with register timer async. We're giving it our time limit. We put 90 seconds up above, and then we'll give it the end turn callback when that timer runs out. We're grabbing our game state, dumping it into JSON here, and then we're going to be pushing that JSON out to our other players. Technically, this is a 1v1 game, so we're only sending it to one other player, but there's nothing really stopping you from creating multiple players. If it's a 4-player game, 8-player game, team game, whatever, you can just send multiple messages to your different players here. And then here you call your push client, send player message. You'll give it your context, which I think is who sent it, and some other metadata there, your actual message, and then the player ID that you're sending it to. And you need to do that for each other player. Doing that again there. And then here for intern, this is what will happen when the timer runs out. We will end the turn. We grab our game state from JSON, which is saved in that string. We'll move the active turn, active player, cancel our timer, advance the turn, set a new timer. Then we serialize the new game state with the new active player, and whatever happens during next turn, all that happens, and then we send out the new game state to everybody. Okay. Okay, and then down here at the bottom, we have our module config. This you'll put in almost all of your modules. And this is the dependency injection part of it here. If you just use config.add game API client, that will get you the other services APIs, like for cloud save, leaderboards, all of the friend system, all of that you can access through this game API. They also recently added the admin API, I think. Yeah, you can also add the add admin API if you want. So now with this, your Cloud Code stuff can do admin level stuff. So it can do things like it can create leaderboards and grab data from other player IDs if you need to. Okay. So I think that is the main thrust of Cloud Code and the different functions and stuff that you can actually do with that. From this point, let's take a deeper look in the actual card game system. This is one I found a while ago, and it is pretty flexible, actually. And and it is just a pure C sharp card game network framework that you can use to create any type of card game, really. And it is really good. So the built-in demo is kind of a Hearthstone style demo, and there's some cards that are already built for us that we can um, hook into and actually use. But since this is all C sharp, there is no graphical component here. So if you needed to tie these cards to in-game representations, you have to do that client side, which is not difficult, but it's just not part of this framework. So we'll show here. This is going to. Yeah. So by default, they kind of ask you to do a NuGet package. You don't actually have to do NuGet through Unity. There is a little bit of cleanup, but you can just drop the entire framework into Unity and it will work. There's just a couple of quirks that Unity does not particularly like the what do they call it? The question mark, the null operator. Which you should probably clean up, but it's not hard to do. It's just in a few places here. Okay, so the actual basics here is you have a game object here that has a number of players, one or more, and you add players to the game object. Each player can have different stats. I think by default, I don't even know if it's even default, they'll have a life value and a mana value here. You can create new stats and add them to your player or your cards. They all have a stat container interface on them. So anything with that interface can have stats added to it. It's just a, bag of stats basically. And then your game state is usually a serialization of your different players. So your players can have collections. So you'll have a collection for your player hand, a collection for your player deck, a collection for what is played on your board, and you can also have a discard if you so choose. So, and those are all just collections of cards. So when you play a card from your hand, you are removing it from your hand collection and then adding it to the board collection. Or it's a spell and it's being used immediately. When you draw a card, you draw the first card from your deck collection, you remove it from the deck collection, and you add it to your hand collection. The cards themselves are component-based. So a monster card will have a monster component. It could also have spell components as well. They'll also could have reactions. So you can have a spell go off on reaction. So when a card is played, that's an action. You can have a reaction to being played that will kind of be a, what is it called in Hearthstone? Battle Shout, I think. Just an on-play ability. And everything is either an action or a reaction. We'll get to that in a second. But cards in this Hearthstone demo, they all have a mana stat, an attack stat, and a life stat. So when you create a new card, all you have to do is give it its stats. So you give it its stats in its constructor. And then if you are creating a different type of card or a different type of game, maybe your game doesn't have mana or attack. Some just have a single like power value. If you're doing Marvel Snap, you just have a energy cost and a power stat. And like I said, the card collections are just kind of like they say, they hold multiple cards in one place. So you'll have hand, deck, and board. And those are unique to each player. So here we are just adding cards to a new deck, and we are just pushing the last card we just created onto the bottom of that deck. And since they're just collections, you can just call .shuffle on them whenever. I think I did that here at some point during testing. I was just straight adding these pre-made cards into this deck, and then at the start of the game you will shuffle both decks, which I may have actually forgotten to actually shuffle. Huh, that's funny. I had not been shuffling decks. What I am planning to do is have a deck creator in game that each of these cards will have their own ID here, and then we can upload a list of IDs that can be uploaded by the player, and then during gameplay here, it can grab these decks from their player data. I think what I'm doing here is when the host creates the game, I think we just grab their decks. Yeah, I'm using this to actually grab the deck from the cloud save. How did I do that? I don't remember if I actually implemented this. So yeah, I was saving these by name, which is probably not a very good way of doing this. And yeah, see, this would be a good case for the admin API. I think I was saving these just to the straight project as custom game data. But this should be from the admin API, and then I can just grab the decks from that player's game save data. That way, I don't need to clutter up the actual custom game data with people's decks. Okay. So yeah, these were saving decks as JSON, which is a way of doing that. But anyways, so for the players, you just create a new player and then you add them to a list of iPlayers. And then each player has the deck that you add for them. Then at the start of the game, you can draw from that deck to make your starting hand. The actual game has actions that you can take for that game. So you'll have like start game, which every game will have, and then next turn, which will advance the turn state. Within that next turn event, you can have various actions like if you're untapping cards, refilling energy, any kind of cleanup or setup for your different cards will happen during the next turn event here. So for this game, there is a cast monster action that the players can call, and you just give it your game state and the card that you want to play. I think this is the slot that you are playing the card on. Some games the slots don't matter. Some games it does matter a lot. So like for Marvel Snap, you have your different locations, and then each location has 4 slots, and those slots can dictate whether you're on the front row or the back row of that location, and different abilities can trigger off of those. For spell cards, in the Hearthstone demo, there are targeted spells and target list spells. And if you are casting either one of those, you'll need to give it its own parameters. Like for target list spells, you don't need to give it a target, but for a targeted spell, you need to give it the target or targets that it needs. Building these cards is all done in code. I tried to have a card builder editor, but it kind of got too complicated, and I'm not sure where I want to go with it because it requires some code generation here because there's no easy way to build your card components and have them saved. So if you create a new monster or a new component, you have to create that component in code first, and it's not an easy like drop down menu to actually build these things. So everything that we do is an action in this framework. So there is a add card to board action. There is a draw card action. There is a end turn action. And I think there is also a on modify life action. So whenever a card or anything with a stat changes, a life stat changes, you can call this this action to do things. So I think this one will check if your life is 0, or if the life stat is 0, it will destroy the card, or if this is the player, it will actually end the game when your life hits 0. If you have life totals in your game. And like I said, there's reactions as well. So this is a draw card at the start of turn event reaction. So basically this will fire off if the action is after the start of turn event. You draw a card for the active player. There's some built-in events here: start of game, end of game, start of turn, end of turn. We've got effects here as well. So for this damage card spell, it's targeted. We give it a damage. This is its constructor. We'll add the card damage spell component to it. Here, we'll give it our list of components and reactions. And this constructor here, this is the spell card component targeted. We give it our damage. And then this damage spell card component can be put on any card. Doesn't have to be put on this specific card specifically. So once you have a component created, you can add this to any card. So if you wanted a monster card to be able to use this action, you could do that. So here we just have the cast override here, and any action is going to be run through your game.execute. So this will update your game state with what we're doing here. So this is a modify stat action. And then we will grab our target and then modify the life stat by that damage. You'll also want a list of potential targets. So you want to know what targets you can target and which ones you can't. This particular spell will be anything that is the other player. Oh, I guess I think this is a damage card. So this will be any player. Anything on the board that is a character can be targeted. So when you are looking to select a target, those will be fair game. So you could even target your own characters if you want. And yeah, the demo project is the Hearthstone project here. I've got it in the editor, and we can look at a little bit here, which is in Hearthstone implementation here. So here we have our monster cards, which are the different reactions and actions here, or spell cards here. These are the game turns that we have here. We have our modify player action here, active player. All this is doing is setting a new active player. This will happen during the turn change. Our next player. These aren't super complicated. Here we're just changing the first player. This is teams here because I wanted to try adding a 2v2 mode into Hearthstone. And then we have our next turn action. So there are different action like timing windows. So there is like execute simultaneously. There's also execute in sequence for some actions. But since this is ending the turn, both players will be switching turns simultaneously. Here we just have the draw card action for our Hearthstone game state, which we can actually look at here. So to create a game, you just inherit from game and then Hearthstone state. The Hearthstone state is just the active player, in this case the active team. We have a list of our players, who the active player is, and who the non-players are. The actual players themselves, which is where most of the actual game state is, they just have a end game here. So this will check if the player's life is 0 or less, then it will just straight up execute the game over event. When that happens, it's just game over. Here, so that action gets added first, and then we create new collections for our deck, hand, board, and graveyard. We'll have a draw card that will execute our draw card action. We have a summon monster that will execute the summon monster action. Same for cast spell. We do want to check if the card is castable first, and then we execute it. For the targeted spells, we do the same thing here. Check if it's castable. And that is actually kind of it here. We can look at how an actual card is set up here. So here we're just looking at a Wisp card, which is just a Hearthstone monster card, and then we give it its mana, attack, and life. And then the Hearthstone card is just whether it's ready to attack or not. Monsters come in with summoning sickness, so when they first are drawn, they are not ready to attack, unless there is another reaction that might make them ready. Here, so we have just one action they can do, and that is going to be an attack. And then there's an attack action here. The attack action is just going to take an attacker and a target